to be a continuation of part A from our very first lesson on the Cartesian coordinate plane. Just like part A, most of the content today will be a review for some of you. So hang with me, skip ahead to parts that you need a little additional support with or use as needed. The Cartesian plane has two real number lines which cross at a right angle at 0. 0 is the origin, as we'll point out down below as a formal definition. But here would be the origin, and it's the point 0, 0. We have the x-axis that is horizontal and the y-axis, which is vertical. So let's say I have the point P, and I'm going to say that that point P is the point 2, -4. So let's imagine that we're dropping a vertical line from the x-axis to P and a horizontal line from the y-axis to P. This gives us the point 2, -4, where we have the x-coordinate and the y-coordinate. The first number, the abscissa, is the x-coordinate, and the second is called the ordinate or the y-coordinate. We'll typically refer them to the x and the y-coordinate. XY lies on the x-axis if and only if our y value is 0. So the point would be x0. So anytime I've got, let's say, this point 3, 0, I know that it's going to be on the x-axis itself because 0 is in the y position. And let's say I have the point 0, 4. I know this is going to be on the y-axis because I'm not moving left or right. Some other things that we need to keep in mind when we're looking at the x and the y coordinate system is that we have quadrants. So the first quadrant is in the top right corner. All points in the first quadrant are positive x's and positive y values. Then we move counterclockwise, so the points to the left of the first quadrant are the second quadrant. And these particular points are negative x values but positive y values. And then the third quadrant, continuing counterclockwise, both are going to be negative x's and negative y's. And then we end up with the fourth quadrant on the bottom right-hand side where we have positive x values and negative y values. There are a significant amount of symmetry within the coordinate plane and system itself. So let's take a look at some of those. Let's say that P and S are symmetric about the x-axis, and Q and R are then symmetric as well across the x-axis. So if I look at P and S, we can reflect P and S across the x-axis. I can do the same with Q and R. They are reflective across the x-axis. And we'll notice what happens when we do that. Notice that when I reflect across the x-axis, notice that our x values remain the same. So here to here, they remain the same. What does change when we reflect across the x-axis is our y values become the opposite. And the same would be true if I reflected S over the x-axis the opposite direction and R across the opposite direction as well. Another symmetry that we have, we'll erase this, is symmetry across the y-axis. So P and Q are symmetric about the y-axis, And similarly, R and S are symmetric about the y-axis. If we reflect across that y-axis in either direction, notice that our y values remain the same. It's our x values, when we reflect across the y-axis, become opposite. Again, our y values remain the same. It's our x values that are opposites when we reflect about the y-axis. There's one more reflection that we need to talk about, reflection across the origin. So if I look at R and P, I can go across the origin, but I notice that when I do that, both the x and the y become opposites. Similarly, if I take Q and go across the origin to S, or vice versa, doesn't matter, both directions, notice that again, x and y become their opposites. So it's changing the opposites in that manner. Let's look at example 1 here and talk about a specific point in the Cartesian plane and talk about its reflection, its symmetry, about the x-axis, the y-axis, and the origin. So let's say I have the point -2, 3. This is point P, -2, 3. What will the point be if we are symmetric about the x-axis? So if I'm symmetric about the x-axis, I'm going to reflect down here across the x-axis. I'm still going to go 3 down and 2 over, except this new point is still going to be -2, but this time I'm going the opposite direction on my y-axis. So the point -2, -3. Let's say I want to take my point and go across the y-axis. So I want to go to the right. I need to go to the right 2 units, but I'm still going to be +3 units up. So this time I'm going to be 2, +3. And then finally, if I want to go across the origin, I'm still going to go to the right 2 units and down 3 units, so I'll be at +2, -3. So notice what happened to our original point and the points with respect to the symmetry. Notice that when we went across the x-axis, the only thing that changed was the opposite of y. So we changed the opposite of y, so it was a +3, which made it a -3. When we went to the y-axis, the thing that changed was the opposite of x. So if I look at our x values, this is the point that changed. And when I look with respect to the origin, both the x and the y value change to their opposite signs. We also want to talk about the midpoint between 2 points on the plane. So the midpoint is simply adding the x values and dividing by 2, and then adding our y values and dividing by 2. So we have the 2 points, -2, +3, and -1, +1, -3. So our midpoint, if I think about this, is our P is our first point, so we'll say x sub 1, y sub 1, and I'll think of Q as our second point, so x sub 2, y sub 2. We can find the midpoint by adding the two x values together, -2 plus 1 dividing by 2, and adding our y values together, 3 plus -3 divided by 2, gives us -1/2, 0. Our distance formula, some of you may be familiar with Pythagorean's theorem, so it is derived from the Pythagorean theorem. Where the distance squared is equal to the difference between our x values squared plus the difference of our y values squared. We then can find the distance between these 2 points by taking the square root of the left and the right hand side. So if I have 2 points the same, -2, 3, and the point 1, -3, we have x sub 1, y sub 1 for our first point, x sub 2, y sub 2 for our second point. Substituting into the formula itself, I want to take the difference between my x values. It doesn't matter which order, just keep it the same. So I'll take 1 minus a -2 squared plus -3 minus 3 squared. Let's see here, this gives us 3 squared plus -6 squared, or 9 plus 36, the square root of 45, which is not a friendly number. However, we can reduce this. I know that 45 is divisible by 9, 9 times 5, and 9 is a perfect square number. So reducing the radical gives me 3 square roots 5 is the distance between the 2 points. So we found the midpoint of -1/2, 0, and we also found the distance between these 2 points. Find all of the points with the x-coordinate 1, which are 4 units from the point 3, 2. So we do know that it has to be 4 units away, so we know that our distance is 4 units. So I want to know what are the 4 units away from this particular point that has an x value which equals 1. So here is a vertical line where x is equal to 1. I want to know what are the distance of those the 2 points that would be 4 units away. What are the y coordinates that match this when I know my distance and I know my x value? So ideally, I know that my x-coordinate has to be 1, but I don't know what my y-coordinates are yet, and that's going to be our goal. But because I know the distance formula, I can utilize the distance formula to help me find this. I know the distance is 4, and I know the distance formula is the square root of the difference between our x values. So here's one value, here's the other. 1 minus 3 squared plus, now our difference in y values. I don't know what this particular y value is, so y minus 2 squared. So we're going to have to solve for this variable. Well, I'm going to need to undo that square root. So to undo the square root, I'm going to square both sides. Now I have 16 is equal to Oops, the square root's gone. 1 minus 3 squared, that'd be negative 2 squared is 4. Plus y minus 2 squared. Now we'll continue solving for y. I can subtract 4 from both sides such that 12 is equal to y minus 2 squared. I need to take the square root of both sides. 12 is the same as 4 times 3 to reduce that radical. So 2 square roots of 3 plus or minus, when we take the square root, equals y minus 2. So y is going to be two different solutions. We're going to have, when we add 2 to both sides, 2 plus 2 square root 3, and y is also going to equal 2 minus 2 square root 3 in its exact form. So there are two answers, one with a positive and one with a negative. I want you to think about why we would end up with those two answers. I'm not going to answer that for you, just ponder on your own what they might be. But there are two answers. So this bottom one is going to be the 2 minus 2 square root 3 in its exact form. Oops, excuse me, 1. That's our y value, excuse me. 1, 2 minus 2 square roots 3. And this one up here is going to be 1, 2 plus 2 square root 3. Please be careful in My Open Math, as they do request exact answers most of the time. It will tell you whether or not you need to put a decimal. And our last problem, it's asking us to verify the distance formula for points that are arranged vertically. What does it mean for points to be arranged vertically? If I've got x and y coordinate system here, and let's say this point and this point, they're arranged vertically from one another, that tells me that they have the same x value. If they are arranged horizontally, they would have the same y value. So if I have two different points here, let's call it point P, would have the x value, let's call it A, it would have some y value, 0, we'll say, or 1. And another Q value that is vertical from P, so let's say this is P and Q, it would also have the same x value, but it would have a different y value. So that's why I'm putting the x values the same as A. Now let's verify the distance formula. The distance formula is the square root of the difference in our x values, so A minus A squared, plus the difference in our y values, y sub 1 minus y sub 0 squared. Well, notice what happens here. A minus A just becomes 0. Well, and 0 plus anything is just the anything itself. So I have the square root of y sub 1 minus y sub 0 squared. I know the square root and the square undo each other. So it is just the difference in y values. Right, so the distance of two vertical points would just simply be the difference in their y values, which actually makes sense if we have this specific problem. If this p value was 2, 1, and this q value was 2, 3, the distance between those 2 points would be 2 units, the difference between our y values. And that concludes today's lesson, and now you're able to do all of lesson 1 in your My Open Math homework.